Hello all, welcome to this class on development of lateral surfaces of solids, and in this class let's try to solve this problem number 3 in development of lateral surfaces. That is, a square pyramid, base side 40 mm and axis length 65 mm, has its base on HP and all the edges of the base are equally inclined to VP. It is cut to with an inclined section plane so as the truncated surface at 45 degree to its axis. Bisecting it, draw the development of the truncated pyramid. Okay, let's try to solve this problem. So this is a square pyramid problem. So far we have done problems on square prism, prisms, and we saw square prism and pentagonal prism problem. So this is a pyramid problem, and the lateral surfaces of a pyramid are triangular in shape, and when it is cut at some angle, it would have some the triangle itself would have some different shapes. Okay, so mostly we'll be constructing in that shape only, so mostly the triangular shapes of something like that, but it will not be of rectangular shape, just like how you saw in prisms. So first thing what you'll have to do it is draw the front and top views, that is orthographic views of the square pyramid, just like how you do in solids. So similarly you start, so first you draw this XY line, and then switch on the caps and see that you try to name it X, Y, and also VP, HP. So once after you have done that, the next thing what you will be doing is, draw this top view. That is, go to rectangle. You can enter the, you'll have to draw this square pyramid. So square pyramid, in the sense, the base will be of square shape, and from all the corners, projections will be drawn, and it will lead to a apex. So on the top it will be just an apex or a point. So only the base will have the true shape. So let's enter the, using the rectangle, let's try to create that square. So let's enter the width as 40, enter height also as 40, enter. Now this is very important. See, it is given as all the edges are equally inclined. When the edges are inclined, that means to say it is not at edge condition, it is at corner condition. So for corner condition, you will always be giving 45 degrees. So enter, and see that you are trying to use visible line for it, because that has to be made using visible line, and then click it. So okay, so I think it is not made visible, so you can try to make that visible again. So you can let's try to make that visible. Try to select that and make it visible clearly. Okay, let's try to make that visible. Okay, so now we have just drawn it. So next thing what you'll have to do it is draw projections, or let's do the naming. That is also, so can switch off the caps, and let this be A, B, C and D, C and D. So A, B, C and D. Okay, next thing is let's try to draw the the diagonal lines. So let's draw diagonal lines, and let's try to name that center as well. Let's try to name that center as O, and now let's try to name it let's try to draw the projections. So we have drawn the projections as well. So now what you'll have to do it is using this center line, or let's use the normal line itself, and see that the axis length is given as 65 mm. So from this center, so let's try to enter the height as 65. 65, enter. So let that be 90 degrees, enter. Now generally in a solids problem you will be joining this using visible line, but here let's join it using normal line first, because only the lower portion of that cutting plane will have to make it visible. So let's not make everything visible at it now itself. So let's try to join that from that apex using here. So you can try to zoom it as well. So sometimes, because most of the times we make mistake here, so see that you don't make any mistakes. So see that from here let's join to this apex, and similarly from here, so using that alignment indicator you can find it correctly whether you're pointing it correct, you're placing your cursor correctly there or not. Okay, so now we have done this. So the next thing what you'll have to do it is do the cutting plane. So use the cutting plane, you can go to this line command and select cutting plane here, and let's try to select that type of line, because this one, if you try to select this, it will be similar to a hidden line. So let's try to select something like this. Exactly at the axis, they are, okay, you can just read the question clearly. They are telling it is cut with an inclined section plane so as the truncated surface at 45 degree to its axis bisecting it. That means to say it is exactly cut at the midpoint. So at the midpoint, I mean, see, whenever you're placing the cursor here, I mean, it shows this, I mean, it indicates you that you are at the center. If you're trying to go bottom or top, it indicates a little bit differently. So that means exactly if you get this indication, that means to say it is at the midpoint. So from there, draw a line, and I mean, let the length be whatever it is, but let the angle be, so 45 degrees. So enter 45 degrees, enter. So just click it. So now what you can do, you can go to this extend to next option and just try to extend that. You can trim this, because in prisms we had, but this one, this is of no use, that extended line and all. So here let's try to trim it. Now the lines below that cutting plane, let's try to make it visible. So let's try to go to a visible line. See that below that cutting plane, you're trying to make that visible, all that portion. So this one we have made it visible. Now it's time to do the namings. So see that the cutting plane is cutting the line here. So let's make that as 1 dash. So I mean, see, I mean, before that, let's try to name this top view also. If this is A, this has to be A dash. So A dash. If this is B and D, B will be visible. I mean, this point B will be visible while point D will be hidden. So point B dash will be visible while D dash will be hidden, and this will be C dash. So now using move option, let's try to move that. So let's place it correctly also. So let's place it somewhere like here. So all these points, and O, even O has to be. So let's place all those points correctly. So see that all the points are placed nearer to that particular corner or point. So don't place it somewhere very back or very far away. So avoid doing that. So let's place it this one somewhere over here. So let this be O dash. So let me name that O dash here. O dash. So I mean, while constructing the top and front views in development, don't expect accuracy, just like how you do in solids. So if there are some slight inaccuracies are okay, they're acceptable. So that is okay, not an issue. So okay, we have done that. So the next thing what you'll have to do it is, you can just see this cutting plane is cutting this front view. So you can just try to zoom this. It is cutting this front view at A dash. So when it is cutting at A dash, let's try to make that as 1 dash in the, because as we are naming it in the front view, let's make it as 1 dash. Similarly, it is cutting the cutting plane at B dash. So let's try to name it 2 dash. 2 dash. Okay. It is trying to cut the cutting plane at C dash. So let's try to name that 3 dash. And it is trying to cut the cutting plane at D dash also. So let's try to name that 4 dash. So 1 dash, 2 dash, 3 dash, and 4 dash. But you can just see exactly, you don't know where it is cutting. So what we'll be doing is, so we'll have to construct that, we'll have to make some slight changes in the top view. So what we can do is just go to a line, just select normal line. So wherever it is cutting here, that from that visible point, from there try to draw a horizontal line first. Then you can just try to, from 3 dash, try to extend that line first. So let's try to extend till here. And from this horizontal line, let's try to extend till here. Now what you can do is zoom that part, and go to this arc by center point. So let this be the center of the arc, and let the second line be the overall, you can just try to select that. You can just first draw an arc, and similarly let this be the center and this be the okay, that's the end point. So we have just drawn an arc now. So what you do now, similarly, see, it is trying to, I mean, from 1 dash, let's try to draw a line. From 1 dash, let's try to draw an horizontal vertical line. So it is cutting here. So from 1 dash we have just drawn a line. Okay. Similarly from this 2 dash and 4, 2 dash and 3, 4 dash we have already drawn. From 3 dash we have already drawn. So now what you have to do it is, you see, this is that 3 dash line, this is that 1 dash line. Here you have 2 dash and 4 dash. So now what you'll have to do it is just join those lines. That is very important. So you take visible line. So from this 1 dash to this arc, let's try to join a line. Similarly from this 1 dash or 1. So from there, let's try to join here. So this one is, this is that line of this 3 dash. So you can just see here from this front view. So this is the line of 3 dash. So what you do from the 3 dash also, let's try to join this side here. Similarly, let's try to join this. So we have joined that one as well. Now what you'll have to do it is make this portion visible. So that is one portion which will be making it visible. Apart from that, even this portion will be made visible. So this portion will be made visible, and this portion also will be made visible. Okay. So now wherever it is cutting, let's try to name that also. So using this text option, so you can just see this is that 1 dash, it is cutting here at A. So let's name this as 1. So let's name that as 1. Let's try to move it later also. So let this be 2. So let this point be 2, let this point be 3. This one you already know it is 3, because here you can just see from 3 dash only we have extended that line here. So let that point be 3 here, and let this point be 4. Now let's try to move that and place it somewhere. So let's place it somewhere like this. So let it look neater. Okay, so now we have finished that part. So now it is important to do the development. So we have just finished that first part of the problem, that is the orthographic projections, all that. So now let's try to delete this line, and we are trying to trim. We can't trim it, so we are trying to reduce that length. So let's try to okay, so now what we can do is, we can just reduce that length. So I'm just trying to trim it and trying to redraw a small line. Okay, so that is fine. So now what you can do is do the development. So for doing the development here in this problem, what we have to do it is, we'll have to first measure the length. So using smart dimensioning, using the smart dimension, let's try to measure that length. So you need to measure this first, this full length. This full length is found to be, you can just check in this box, it is found to be 70.89. So that length is found to be 70.89. What you do is go to line, go to visible line, first draw a line at 70.89. So first draw a line at any angle 70.89, enter. So what you do later is, once you do that, you can instead of drawing line, okay, don't draw a line, you can just use that as for cutting an arc. Okay, go to arc. Okay, go to arc by center point. What you can do is give the radius as 70.89. Don't draw a line but cut an arc. So see that from somewhere, from like, keep center as somewhere. First cut, draw, draw it correctly. So see that, go to arc by center point, give the radius as 70.89. 70.89 is nothing but this length. So this length, that side view of the triangle. So just draw an arc at any, let that swept angle be whatever it is, for how much ever you want, you just draw an arc. Okay, doesn't mean only for so much angle, nothing like that. Whatever how much ever possible, you try to draw a line. So now go to line again. If you just place this cursor, you will get that center. So from center, you try to draw a line from here as well as from here, using a visible line itself. Later on, what you can do, later on you can try to draw that using a normal line. Later on you can try to make that visible. So make that normal. Only minor portion of it will be drawn using a visible line. Now what you can do it is, go to arc by center point again, keep at this point, give the radius as, you can just see the square prism's base side is 40. Therefore, cut arcs at regular intervals of 40. So 40, give a radius as 40, cut an arc. Okay. Now keep your center here. At this arc, wherever it is cutting that, this bigger arc, give again, what to say, radius as 40, enter, cut an arc again. Now again go to arc by center point. Keep your center as at here where the smaller arc is cutting the bigger arc there. Give the radius again as 40. Enter. Now again go to arc by center point. Keep the center here and give the radius as 40. Enter. Okay, so now we have just drawn 4 points. So you see you need to totally draw 4. So because you totally have 4 points, that is A, B, C and D. So therefore 4 arcs are enough. So like that, that means you'll be getting like 4 different triangles. So what you do, wherever that smaller arc is cutting bigger arc, from there you join it to the center using a normal line itself. From there you just join it to the center. It is like you'll be getting 4 different triangles. So as I told you, see this square pyramid lateral surfaces will be of triangular shape, so that is why. So you will be getting 4 different triangles. So you see after getting that 4 different triangles, here is that extra portion. You can try to trim that extra portion that may not be required, so you can trim that last part. So that is fine. So now what you can do is go to this text option and name it. So name it using caps A. Let this be B, let this be C, and let this be D, and let this be A again. So we have just drawn that. So now see here, it's very easy now. So you can just try to zoom this part. So here, whatever from that A dash to 1 dash, this length is what you're going to mark here. From A dash, from this part to, you're going to mark it here. And similarly from B dash and D dash, it is this length, whatever, see whatever I'm trying, I'll highlight it now and show you. So this length actually. So from B dash to 2 dash, 4 dash to D dash, and similarly C dash to 3 dash, it is this length. So you will have to split those lines. So those lines have to be split. So now what you can do is go to split option and try to split those lines. So that is very important. Go to split option. You find split option in this trim. So you can select this entire line, split here. So you will get that. Similarly, select this entire line, split at this 2 dash and 4 dash. Similarly, select this entire line and split at this 1 dash. So now what you do, you will get this individual dimensions. So this dimensions here, it is not shown correctly, but here you can just see it is showing 8.14. So you can try to fit this. What you can do next is zoom this part. That is zoom this part and make that 8.14. From here, draw a line at 8.14. So enter. Similarly, you have A here also. From this end at 8.14, draw a line here as well. So now again go back to this front view. Here you can just let me try to delete this, because as I told you, here it is showing in my computer isometric dimensions, but in the exam you can just show those dimensions. I mean, not an issue. Now using this smart dimensioning, show these dimensions. The dimensions you can check it over here, that is found to be 32.5, and similarly let's try to measure this also. That is found to be 46.13. So 32.5 from B and D and 46.13 from C. So 32.5 and 46.13. So go to line. So from here B, 32.5. So just draw a line upon that itself, 32.5. Enter the length as 32.5. Left click and right click. Similarly from D. So from D, draw a line 32.5. Enter, left click and right click. From C, so from C, let's try to enter that length as 46 point. So enter 46.13, enter. So now we have just got all those points. So now what you will have to do it is join those ends of that visible line. You can just see only partially visible, only that wherever it is visible there you can try to zoom it as well if you want. And try to only join this ends wherever it is wherever it ends at that visible portion. So from there let's try to join at all these points, and what you can do is do the naming. So let this portion be 1 dash, let this portion be 2 dash, let this portion be 3 dash, so let this portion be 4 dash, and let this portion be 5 dash. And you can try to trim this extra lines, whatever you want to have, you can try to trim it. So finally, you can just try to show these dimensions also if required. This one, the 70.89, all that. But as I told here, I can't show in my computer. Um, so now you can try to mention this as development. Okay. So I think with that, the problem gets over. So you can try to mention your USN at the end. So I hope you understood this problem. Thank you for watching. Take care.